There's no direct prohibition in the National Electrical Code, specifically within Section 518, that prevents the grouping of ground fault circuit interrupter, or GFCI, receptacles in public assembly buildings. However, it is important to understand the potential implications of such a configuration. GFCIs are critical safety devices designed to protect individuals from electrical shock hazards. They function by constantly monitoring the current balance between the hot and neutral conductors in a circuit. If a ground fault occurs, meaning that current is leaking to ground through an unintended path, the GFCI will quickly trip, interrupting the circuit and preventing a potentially dangerous shock. The issue with grouping multiple GFCIs on the same circuit stems from the fact that a single ground fault can potentially trip all of the GFCIs simultaneously. This is because GFCIs are designed to be highly sensitive to ground faults, and even a small amount of leakage current can trigger a trip. If multiple GFCIs are connected to the same circuit, they will all be exposed to the same ground fault current, and each one may interpret this as a hazardous condition, causing them to trip. The consequence of this simultaneous tripping is that a large area served by the circuit could be left without power. This could be problematic in a public assembly building, where a sudden loss of power could create a safety hazard or disrupt activities. Consider, for instance, a scenario where a ground fault occurs in a lighting fixture connected to a circuit with multiple GFCIs. If all of the GFCIs trip, the entire lighting system for a section of the building could go dark, potentially leading to panic or accidents. Therefore, while not explicitly prohibited, the practice of grouping GFCIs is generally discouraged. A more effective approach is to distribute GFCIs strategically throughout the building, ensuring that each GFCI protects a specific area or piece of equipment. This minimizes the risk of a widespread power outage in the event of a ground fault. Furthermore, it is important to consider the overall design of the electrical system in a public assembly building. The system should be designed to minimize the likelihood of ground faults and to provide adequate protection against electrical hazards. This may involve the use of isolated ground systems, surge protection devices, and other safety measures. In addition to the technical considerations, it is also important to be aware of any local codes or regulations that may apply to the installation of GFCIs in public assembly buildings. Some jurisdictions may have specific requirements regarding the placement and spacing of GFCIs. It is always best to consult with a qualified electrical inspector to ensure that the installation meets all applicable requirements. To further elaborate, let's consider the implications of using a standard circuit breaker instead of a GFCI circuit breaker in a situation where multiple GFCI receptacles are installed downstream. A standard circuit breaker is designed to protect against overcurrent conditions such as short circuits and overloads. It does not provide the same level of protection against ground faults as a GFCI. If a ground fault occurs in a circuit protected by a standard circuit breaker, the breaker may not trip unless the ground fault current is high enough to cause an overcurrent condition. This means that a person could potentially receive an electrical shock before the breaker trips. In contrast, a GFCI circuit breaker is designed to trip quickly when it detects a ground fault, even if the ground fault current is relatively low. This provides a much higher level of protection against electrical shock hazards. Therefore, it is generally recommended to use GFCI circuit breakers in areas where ground fault protection is required, such as bathrooms, kitchens, and outdoor locations. Another important consideration is the testing and maintenance of GFCIs. GFCIs should be tested regularly to ensure that they are functioning properly. The manufacturer's instructions will typically provide guidance on how to test a GFCI. In general, GFCIs should be tested at least once a month by pressing the test button on the device. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. In addition to regular testing, GFCIs should also be inspected periodically for any signs of damage or wear. If a GFCI is damaged, it should be replaced immediately. Proper maintenance of GFCIs is essential to ensure that they provide reliable protection against electrical shock hazards. Regarding the specific Section 518 of the National Electrical Code, it is dedicated to places of assembly. Places of assembly are defined as buildings or portions of buildings used for the gathering together of 100 or more persons for deliberation, worship, entertainment, eating, drinking, amusement, or awaiting transportation. Examples of places of assembly include theaters, auditoriums, churches, restaurants, and transportation terminals. Section 518 contains requirements for wiring methods, conductor sizing, overcurrent protection, and other aspects of the electrical system and places of assembly. The goal of these requirements is to ensure the safety of occupants in these buildings. While Section 518 does not explicitly prohibit the grouping of GFCI receptacles, it does emphasize the importance of providing adequate protection against electrical hazards. As mentioned earlier, the grouping of GFCI receptacles can potentially compromise this protection by increasing the risk of widespread power outages. Therefore, it is important to carefully consider the potential implications before grouping GFCI receptacles in a place of assembly. In addition to the general requirements in Section 518, there may be specific requirements that apply to certain types of places of assembly. For example, there may be specific requirements for the installation of emergency lighting in theaters or auditoriums. It is important to consult with a qualified electrical inspector to ensure that the electrical system in a place of assembly meets all applicable requirements. The National Electrical Code is a comprehensive set of standards for the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect changes in technology and best practices. It is important for electricians and other electrical professionals to stay up to date on the latest edition of the NEC to ensure that their work complies with current standards. In conclusion, while the National Electrical Code does not specifically prohibit the grouping of GFCI receptacles in places of assembly, it is generally not recommended due to the potential for nuisance tripping and widespread power outages. A more effective approach is to distribute GFCI strategically throughout the building, ensuring that each GFCI protects a specific area or piece of equipment. It is also important to consider the overall design of the electrical system and to be aware of any local codes or regulations that may apply.